Good morning. Let us study today perturbation theory. What is called perturbation theory? We have already studied the approximation methods. There are two approximation methods, perturbation method and variation method or variation theorem to solve the Schrödinger wave equation of polyelectronic atoms or multi-electron atoms. It is very difficult to solve the Schrödinger wave equation of polyelectron atoms. For example, let us consider helium atom. Helium atom consists of two electrons. The Schrödinger wave equation can be exactly solved only for hydrogen and hydrogen-like atom. We have already studied. Why for multi-electron or helium atom it cannot be solved? Because let us see the Hamiltonian operator. Let us write the Hamiltonian operator of helium atom. We have already seen how to construct the Hamiltonian operator for multi-electron atom. So, this is the Hamiltonian operator for helium atom in atomic units. In the Hamiltonian operator, the first term corresponds to the Hamiltonian operator of electron 1. This is kinetic energy operator of electron 1, potential energy operator of electron 1. The second term corresponds to the Hamiltonian operator of electron 2. The third term corresponds to the interelectronic repulsion term. The third term is called interelectronic repulsion term. Therefore, because of this term, the Schrödinger wave equation cannot be solved exactly, because it cannot be split into two one-electron wave functions or wave equations. Therefore, we apply the perturbation theory. Let us see the perturbation theory now. What is perturbation theory? H cap, this Hamiltonian is split into two parts. This Hamiltonian, therefore, this Hamiltonian is split into two parts. H cap prime, H naught cap plus lambda H cap prime, where H cap naught is called unperturbed Hamiltonian. H cap naught is called unperturbed Hamiltonian term, and H cap prime is called perturbation term. Because of this, the wave function could not be solved exactly. Therefore, this term is considered as perturbation term in perturbation theory, and lambda is called perturbation parameter. The perturbation term is always smaller than the unperturbed term. This is smaller than unperturbed term, and H cap prime equal to 1 by R12. If lambda equal to 0, see, there are two cases. If lambda equal to 0, the perturbation term is not considered. If lambda equal to 1, please write, if lambda equal to 1, the perturbation is fully applied. Okay. Now, let us see the Schrödinger wave equation or the eigenvalue equation for H cap naught psi n naught equal to En naught psi n naught, where psi 1 naught, psi 2 naught, psi 3 naught are the eigen wave functions of the unperturbed Hamiltonian. E1 naught and E2 naught, E3 naught are the eigenvalues of the unperturbed Hamiltonian H cap naught and their corresponding eigenfunctions. Let us now see the psi n and En. Psi n and En are the eigenfunctions and eigenvalues of total Hamiltonian operator. The eigenvalues and eigenvalues are expressed in the form of power series of lambda. expressed in the like virial equation you have studied. The eigenfunctions and eigenvalues are expressed in the power series of lambda. Therefore, psi n naught plus lambda psi n 1 not to this power lambda square, this is psi n 2, this is not square. Okay, if lambda equal to 1, then 1, 1, 1, it will be simplified. Similarly, En equal to En naught plus lambda, it is exactly written in the same form, En 1 plus lambda square, En 2 plus etc. The first term is the unperturbed energy or unperturbed wave function, the wave function for unperturbed system, the first order, and the second term is the first order energy correction. First order energy correction, first order wave function correction, first order wave function correction, and this is the second term, the third term, sorry, first term, second term, the third term is called second order energy correction. Here, this is second order wave function correction. Because of the higher orders, perturbation terms are smaller and smaller, the higher order terms are negligible. Let us consider only the first order correction. We will consider this first order perturbation theory. Psi n equal to psi n naught plus lambda. Okay, so let us not bother about the higher order terms. Higher order terms are neglected because they are very, very smaller. They are becoming smaller and smaller. Okay, so psi n equal to psi n naught plus lambda psi n 1, En equal to En naught plus lambda En 1. Now the first order perturbed, first order corrected wave function. The first order, this is the wave function of the unperturbed. It is obtained from hydrogen atom. The unperturbed wave function is obtained, unperturbed energy or obtained from the hydrogen atom. Hydrogen atoms we have already solved. Only we need to worry about this term. We need to obtain this term. Therefore, the first order corrected wave function psi n 1 equal to, this is obtained mathematically. It is a tedious process. So this was asked in CSIR. So please remember this equation. The first order corrected wave function equal to summation of n not equal to n, and this is the bracket notation. This is the integral form. Psi n naught h cap psi m naught divided by En naught minus Em naught psi m naught. Similarly, for energy, this is the zeroth order energy. This is the first order energy. How this first order energy is obtained? This first order energy En 1 equal to psi n in bracket notation. Okay, and this is in integral notation. We have already studied. This is equal to expectation value of the first order perturbation energy is equal to the expectation value of energy, perturbed energy. This we have studied in the postulates of quantum mechanics. Similarly, the second order energy correction, the second order perturbed energy, the third order energy correction, nth order energy correction can be obtained by using these integrals. En 2 equal to psi n naught h cap prime psi n 1. Okay, 2 means 1, 3 means 2. The other terms remain the same. And En psi n minus 1. Therefore, for the calculation of En nth order energy correction, we require the knowledge of psi n minus 1 corrected, n minus 1 order corrected wave function. Okay, for example, En 3, in order to obtain the energy of this is first order, second order, third order. So third order correction, we require second order corrected wave function. Second order corrected wave function. Okay. So this is often this formula was asked in CSIR. Please understand the fundamental so that you can let us apply in the next class for helium atom and also unharmonic oscillator. Simple harmonic oscillator, it can be readily solved. Let us apply this perturbation theory to unharmonic oscillator and other problems, etc. Thank you for watching.